Parallel and series circuits by me and Caleb. Our technology is snap circuits, and our launcher was L3 snap circuits, series, and parallel circuits.
SMART goal. Our challenge is to learn how to make parallel and series circuits and how they work. We will use snap circuit kit to create parallel and series circuit by following the guide in the SMART Lab launcher. We should complete all the different kinds of circuits the launcher has layered out for us in the Do It tab. They should all work and do the operation they're supposed to. We will know this and see if they are doing the required functions. We have snap circuit, the Do It tab, and all the previous knowledge of circuits and snap circuits. We are doing this because we are interested in circuits and tinkering to make things work, and it is surprisingly easy to understand. We will complete a circuit and tinker with it on day 1, complete the next one and tinker with it on day 2 and day 3. We will complete 2 circuits and try to make our own circuit on day 4. Yeah.
About your technology. Snap circuits is a kit that contains different electrical parts and wires that will help you build a circuit that will power different things like a light or a fan. Snap circuits will teach you how to build different kinds of circuits such as series circuits and parallel circuits. Snap circuits require no tools as all the components just snap onto the board and onto each other. It will teach you how resistance and currents work. The site gives you 2 battery stations where your current will get its power from, and then wires that are rigid, and all the resistors and other things that are part of a circuit. The kit is like Legos as it gives you a set of instructions and has a picture to follow. This is an example of a snap circuit.
Relate your launcher to the real world. Our launcher is used to turn on multiple load devices from a power source. Parallel circuits are needed for vehicles that have headlights, taillights, radios, and attachments. Series circuits can be used as a voltage divider and translator. Another use of series circuit can be for string lights and flashlights. And final use of series circuits are single path currents, same currents, and voltage drop. That's an example of the real world circuit and our circuit.
What problems did we have? Our biggest problem was getting the wires to stay on because sometimes they don't like to snap on. When we used the multimeter reader, we didn't have the correct settings, so we weren't able to get the readings. We overcame our first one by trying different ways, and that helped, and overcame the multimeter problem by consulting Ponzer about our issues. These are the wires that weren't wanting to stay on.
Explore day. A series circuit is multiple power sources and or load devices that are arranged along a single path. In parallel circuit, multiple power sources and or load devices are arranged with independent paths. We will use a digital multimeter to measure volts, amps, and ohms. We will have to keep a careful measurement of the amps. We will be making a series circuits with the parts from this snap circuit kit. We will be measuring the amps and that it puts out after we add multiple lights. Series circuit example.
Day 1. Today we made our first parallel circuit and we tinkered with it to make the fan super fast. We learned how not to short circuit something and how it needs to be closed all the way around. So we had a challenge with short circuiting and getting the rigid wires to stay on. And this is our project.
Day 2. Today we learned how to use the and read a digital multimeter. This is equipment that reads volts, amps, ohms, and we used the multimeter and we made another circuit and measured how much energy output we have. We struggled reading the multimeter. We overcame this by looking at the launcher. Day 2 project.
Oopsies.
Today we learned how to read, use and read a digital. Yeah, this is the same thing. But on day 3, we made a series circuit that used a light and a fan that put load on the current. But yeah, I guess I didn't do that. Oops. But yeah, that's a series circuit.
Day 4. Today we made 2 circuits, one a parallel and one a series. They both worked and we tried to use as many parts as we could. We tried getting the speaker to work, but it failed because we didn't know how to connect it. Poncho helped us, but it still couldn't figure it out. Day 4 project.
Digital multimeter. The digital multimeter is used to measure volts, amps, and ohms. The DMM has a range that you cycle through until it makes sense. The parts of the names are digital, multi, and meter. Digital means that you read the numbers on an LCD screen instead of an analog needle indicator. Multi means that for the different volts, amps, and ohms setting. Another thing about the DMM is different ones have different ranges for the AC and DC voltage, which is alternating current and direct current.
Conclusion. Our challenge is to learn how to make parallel and series circuits and learn how they work. Yes, we did achieve our SMART goals as we completed all the circuits and managed to make our own that work better than the drums on the launch. Yes, we would. The only thing that we would change is we would use the internet for ideas for circuits we could build. We liked how to show and explain how the circuits work and how each circuit is used. We completed all the circuits and understood how they worked. We also made our own circuits. What was something new that you learned? We worked well together as we both did even work and there was no disagreements on anything. The best thing that is an introduction to the world of circuits and electronic engineering.
Yeah! Oh, some big hands.
We got 66.
You just did. I have 109.
I want 108.
No. You guys are up.
Oh no, I don't have no page. Come back, you just call. Fisher Technic Green Energy by Hanson Jerry. Technology is Fisher Technic Green Energy. Manufacturer is L1 Fisher Technic Green Energy and Alternative Energy.
I'm Jerry, by the way. Smart goal. Our challenge is to decide what form of alternative energy is the best to generate electricity in your location based on research and data collection. You will research wind, solar, and hydroelectric power. You will then build a model of one of these forms using Fisher Technic Green Energy. Specific. We will use Fisher Technic Green Energy, alternative energy to create a windmill that we will be able to find out how much energy it can produce. We will do this by using the kit and the instructions. Measurable. In these 4 days, we will be able to make a windmill that will be able to power a little light, and then we will know that it works. Attainable. What resources do we have to reach our goal? We will build windmill before, so we have past knowledge and we read the what you should know is that. So we have that knowledge too. We are creating this because we both think this will be fun. We will reach our goal by day 1. We will start building it, but we won't finish it, and then we will finish it on day 2, and then we will test it on day 3. Then finally, on day 4, we will change it and upgrade the model so it's better.
About Maury's technology. Our technology is used every day by producing energy for very important stuff like powering homes, businesses, and transportation. Renewable energy comes from sources that are naturally replenished and won't run out, like sunlight, wind, water, and heat from the earth. Jerry and I built a windmill that produced 2.10 volts. The huge windmill turbines typically produce between 540 and 690 volts. That's the windmill with the multimeter that we built.
Relating on to the real world. Biological relates to the real world because you build the things that they use in real life to produce renewable energy. We built the windmill to see if we could produce renewable energy, and we did it. We did get it to work. There's our wind turbine. There's a real world wind turbine. It's pretty big.
What problems did you have? We had problems getting the rubber band to stay on when we were making the windmill spin. We had problems getting the pieces in the right spot because it was hard to see where all the pieces were supposed to go. That's me with the windmill.
Well, what did you learn? We learned how to read a multimeter and what green energy is, and all the different things it can produce. We learned about tectonic plates and how volcanoes are formed.
Yeah, that's
Tectonic plates, there's volcano. It's even formed.
Day 1. Our day 1, we learned that there are many types of renewable energy sources, including the sun, wind, and water. Lastly, I learned that Fisher Technic modeling kits are used by many scientists and engineers for modeling and experiments. That's Poopy Boy with the windmill is Gary, and then I don't know what that is. But
Billy Bob, that's our partner.
That's one of like the 3D images that you can like spin around.
Yeah, that's actually our partner. He was here today. On day 2, today we started to build our windmill with the provided instruction manual. We didn't finish the build today, but we made a lot of progress. We learned how to follow the instruction manual. A challenge we had was finding some of the hard to find parts in the box. We overcame our challenge by looking harder. I feel like we did a lot today and got what we needed to do finished. Let's begin with this.
Know what I'm doing. Yeah, that's me and Jerry with the kit we used. Our day 3. Today we finished the windmill, but some things didn't work. We had to move some stuff around and fix some things. We learned to use we used the air gun to run the windmill. This launcher relates to real windmills that power cities. A challenge we had was getting the rubber band to line up with the thing that powers the light. We solved the problem by adding a piece to hold it in place. Us with the windmill.
I really love the windmill. On day 4. Today, we finally got the rubber band fixed. We had a challenge getting the light on. We solved this by putting the wires in another place. We ended up getting we ended up getting the light green. We used the multimeter to test the voltage, and it came out to be at 2.1. We used the blower to simulate wind. There's the windmill up there.
Day 4. Our day 4. Today we
You just read this.
Yeah. Our challenge is to decide what form of alternative energy is the best to generate electricity in your location based on research and data. I don't think this last sentence really has anything to do with it. We did meet our SMART goal. We completed the goal by getting the windmill done on the second day. We followed the instructions and we built it correctly. We would do this launcher again because we thought it was fun and it wasn't too hard to build. We managed our time by getting all the pieces and working on the windmill and completing it. Some successes we had was getting it built and we built it correctly. That we got it to produce energy. We both learned about renewable energies and we also learned how to read a multimeter. We split the work by one of us getting pieces and putting together bits of it and then putting it on the windmill. Next time I'd get it done, or I would get it done faster and be more efficient with our time, so we could try to get more energy out of it. Collaborated by working together and both doing a lot of work. The questions we still have: if we could get it to produce more energy and how we could make it produce more energy.
Vocabulary. Boy, can we kiss now?
Yeah, bro.
Oh, oh.
Oh, why are your hands wet?
Stop squeezing my thighs.
I want a 0.
Come back, you just call.
We're going last. What?
Next, I need Natalie. Yes.
Our SMART goal. Our challenge was to explore how levers work by creating our own lever machines with Connects and analyzing their parts. Our SMART goal. We will use Connects and the instruction manual to create different kinds of simple machines. In these 4 days, we will be able to design at least 3 different machine models. We can accomplish this because we know about simple machines. We are doing this because we want to learn more about how levers work. On day 1, we're going to explore the pieces we have and look at the instructions and possibly start building. Day 2, we'll build some of our machines. Day 3, we plan to finish building the rest of our machines. Day 4, we're going to evaluate the design of our machines and test how they work.
Our technology Connects was purchased by Basic in 2018, and Connects parts are manufactured in America. Connects is a construction method system where you have many pieces that interlock together with all the pieces. You get in a kit. There is a large variety of models, machines, and other structures. You would be able to build Connects was made for STEM learning and to understand science and its technology better. It allows builders to design working models with some Connects also encourages problem solving skills as people explore different designs and try to build what they see in their
That's our resources. Relate your launcher to the real world. These are like levers that you use, and then those are the things we build. Every day from when you wake up to when you go to sleep, you interact with machines. Levers can be used so that a small force can move a much bigger force. This is called mechanical advantage. Levers are used for transferring force and making it easier to lift heavy objects. We made our levers to show how they work and identify the fulcrum of each one. Levers in real life are often used daily without you even knowing. It's as simple as a light switch, which that is a lever. Levers are found in many everyday objects and are also essential components of the human body.
what problems we have had. Our challenge we had was making stars into small pieces connect correctly. We overcame this by trying different methods and looking closer at our construction manual. Another struggle we faced was communicating between the two of us. Communicating got quite difficult as we quite often had disagreements and wanted to do it one way or another.
what did you learn? One of the main things we learned is that there's different classes of levers. We learned that how machines work is called the study of dynamics. Throughout building our levers, we learned about the fulcrum on each machine. Resistance, we found out, is closer to your fulcrum. This is the different classes of levers.
Sorting. There are 6 kinds of simple machines. How machines function is all the study of dynamics. During the time we will build a few clever machines using Unix. With the models we are going to build, we are going to identify parts of the levers. We're also going to try to figure out how mechanical advantage makes the work easier with each.
Day 1. Today we gathered our pieces and explored the different ways they can be built together. Once we knew what we were doing, we started building our first model. We discovered how to find the fulcrum on a design. On a wheelbarrow, it was the wheel.
Day 2. Today we built a seesaw. While building this, we learned that when resistance is closer to the fulcrum, you need less effort to balance it out. Example: if an adult is on a seesaw and a child gets on the other side, the child will have a challenging time to use their force to get the adult off the ground and into the air.
That's our seesaw. Day 3. Today we worked on building a balance. A balance is classified as a first class lever, and the fulcrum is the stand in the middle. Because with the force on each side, that is where the balance pivots. After we worked on our model, we spent this day looking over some of the projects we had already built, and then got caught up on our journaling for these projects. That's
Day 4. On this day, we completed our SMART goal by building our last design, which was a scissor. We figured out that the fulcrum on the scissor is at the middle point as well as the scissor is a total first class lever. While building this lever, there was a slight pulley on taking each side of the scissors the right way, but with the help of our instructions, we figured out how.
that's our scissors. Conclusion. Our challenge was to explore how levers work by creating our own lever machines with connects and analyzing parts. We achieved our SMART goal. We successfully made 4 different levers, which was over our goal of what we wanted to do. With the time that we were allowed, we split up what machines we were going to design each day. Between my partner and I, we split up the work well, allowing the both of us to each build at times while the other person figured out something else about each machine. If we did this again, we'd like to learn more about the different classes of levers to make it easier to identify the class of each of the models. Collaborating with my partner wasn't the easiest thing to do because we often had disagreements, but we got over those and figured out our problems. The question we still have is what makes levers fall into different class groups. Those are like examples of different levers.
How was that camera like?
Oh, so if we choose, you should do 1 out of 1,000, and if we pick the right number, we don't present.
Quit copying me, I already did that.
Yeah, and you didn't get it, so.
No?
Oh.
1 out of a million? 1 out of a billion.
You like, you tweeted on.
Ah!
You can do this.
What?
Yeah, we would've.
Yeah, we literally would've.
That was not your green energy kit, by the way.
It was on our launcher. That was our picture on our launcher.
Black box?
Yes, it was.
Can
We
you
can
use
go. Do you want us to show you? It was on our launcher.
Well, that's
Getting
not
quite
the kit.
defensive.
Yeah, it's yours.
Present!
It's not longer.
It's not the kit that
Quite
you use.
defensive.
Hey, shut
I
up.
feel like
Stop
you might be
circuit
lying.
green energy. My name's Haley.
My name's Kinsey.
Our technology was green energy, and our launcher was L2 snap circuits, motors, generators, and green energy, and that wasn't our green energy kit, but it was on the launcher. Write that down.
Okay, SMART goal. Our challenge is to build model circuits to explore motors, generators, and green energy. Our SMART goal. Specific, we will use snap circuits green energy to create a generator by following instructions and getting help if we need it. Measurable. In these 4 days, we will be able to create our own generator and follow the instructions of the generators they give us to build. Attainable. What resources do we have to reach our goal? We have prior knowledge to this because there is a windmill on by us. Relevant. We are creating this because it was in the launcher. It was the launcher we were most drawn to. It was also the easiest one we could find. Time days. We will reach our goal by, on day 1, we'll figure out which generator to build first and start building it. On day 2, if we have not already finished it, we will, and then we'll start another generator. On day 3, we'll finish our second generator and most likely start another generator. On day 4, we will finish our projects up and make sure they work how they're supposed to and how we would like them to be. If we have time, we will try to fit in building our own generator.
About our technology, we use the Snap Circuit Green Energy Kit to build multiple projects. We use the instructions to guide us through building these projects. In the kit, there was snap circuits, rechargeable batteries, solar cells, geared motor, black and red jump wires, motor, meter, and the pivot base in our stand. Our technology taught us about green energy such as solar power, battery power, and wind power. We use our technology to teach us how to build different projects, including generators, motors, and wind energy. Compared to normal snap circuits, we have more technology for green energy, while the other kit has more electrical parts. Regular energy is used from fossil fuels, and green energy is generated from elements, and that's some of our pieces from our kit.
Relate your launcher to the real world. People use a windmill to conduct energy for their towns. The wind makes the turbines move, which that power goes into a battery for non-windy days so that it will hopefully still charge. Both of these objects use generator to convert the mechanical energy of the spinning blades into electrical energy. Some differences are that the one from our kit is much smaller than the real world. Snap circuits windmills are designed for safe, while real windmills are built to withstand harsh weather conditions and operate for extended periods. Real windmills are designed to be integrated with electric grids, while snap circuits windmills are not. This is the windmill from our kit, and that's a real windmill.
Oh, screw. What problems did we have? One of the first problems we had was making sure every piece was even so that the power would be distributed evenly. We overcame this challenge by noticing that the project was not working like it was supposed to. Another challenge we had was we built a solar project. We used a light that was not bright enough to conduct power. It needed to get the other source. So we fixed the problem by asking Mr. Ponte to help us brighten the flashlight. One of our last projects, we had a problem with the base grid. It was not letting the piece connect on the board like it was supposed to. We fixed this by building more projects it would. So we'll loosen up the board and make sure the piece connects like they're supposed to. That's our base grid instructions.
What did you learn? Something we learned was that most methods of electrical power production use energy to power a generator. The spinning of the generator can be caused by forces such as the wind, water, pressure in dams, or steam pressure created by burning fuel. Most generators and motors rely on electromagnetism. Around 10% of our energy comes from renewable sources. We learned how solar energy and battery-powered energy work. We learned every piece has to be connected properly or it won't work. We also learned that you can use liquid as battery acid. Also, we learned that you have to put liquid in the previous circuit. And then this is what we learned about how much the U.S. considers energy.
Our Explorer Day. On this day, we explored our launcher and our website. We figured out what we were going to do and what we wanted to learn about. We read the what you should know tab and explored the do a day tab to find out what we were going to do. We learned all about generators and power hydroelectric energy. Some examples would have been windmills, dams, and solar power. In this launcher, we had to build a certain amount of generators as started in our STEM goal, as stated in our STEM goal in the question area. And when we finished with the generators, we had to build our own generator. That's a picture showing some green energy stuff.
Day 1. On this day, we built a solar-powered project and a battery-powered project. These projects were easy to build and one of the first starter projects. We learned how solar energy works and how battery power works from our projects. We had a success with building a few projects. Tomorrow, we plan to make a wind energy project. And this was our solar-powered project.
Day 2. On this day, we learned about how you can use liquid as a battery acid. We also learned that we had to put liquid in it to create the circuit and how it works properly. We found out that our project can be used daily to power many homes and businesses. People can use windmills to generate energy. That's our wind warning project.
On this day, we learned how to make more projects with voltage. We also worked on splitting currents. We were able to build 5 projects today. We had a challenge with the flashlight and solar panel because our flashlight was not bright enough to set off the power from the panel. And then this is our battery power.
Day 4. On this day, we learned how to build a circuit that was called close the door. It taught us how you can switch the controllers so you can turn on and off the voltage that would turn on and off the lights. We had a slight challenge at first, how difficult it was difficult our pieces were being. Then they were not staying properly on our base grid. We overcame our challenge this day by building more projects so the board would break in and make the piece connect easier. And that's our project called the closed door.
Conclusion. Our challenge is to build model circuits to explore motors, generators, and green energy. We would both state that we met our SMART goal. We stated in our SMART goal that we only had to build 4 generators, and we ended up building the whole book. We managed our time very well. We had lots of time in the day to do more than one project and still have lots of time to do our journals. We didn't have to split the work much because everything was equal. If we could do this launcher again, we wouldn't do anything differently. We worked together perfectly and have no complaints. We didn't have any more questions. We think the launcher and the instructions covered most of the ones we did have.
And for our bonus for learning something new with PowerPoint, we learned how to create custom templates or modify existing ones to make personal styles.
What?
How did you implement that?
Huh?
Yeah, I didn't see that implemented in your PowerPoint.
Yeah, you didn't.
When you
add
added.
When we added the pictures, like, or we could.
Whoa!
It just looks like the base PowerPoint.
I don't know. Google told us how to do it.
Well, clearly you didn't
And
do it.
another thing
'cause
we could also learn. Oh, go back to this side. This one.
You clearly.
I learned how I could put this picture. I could send it to the back so my arrow wouldn't be completely covered by.
You knew
Google
how to
showed us
do
how to
that.
do
No,
it.
I didn't.
Yes, you
Google
did.
showed how to do it.
We
I did
literally
not
learned
know.
how to do that in there, so that's not something new. We learned about.
Google